We're going to take a look at our chi-square problems from last week and then get some new ones for this week. So remember, as a review, the chi-square test is important in science and AP biology. It's a way to compare when you collect data if the variation in your data is due to just random chance, or if it's due to something funky going on, like something is wrong with one of the variables that you're actually testing. So to make it fun, I use the M&M example. First of all, remember this is our chi-square equation. Remember, in the end, you're actually not going to square your answer. I know it's called a chi-square test, but you're not going to square your answer. That's just the name of the actual test. So this symbol stands for chi-square, and this symbol always looks scary, but it just means that you're going to do the sum of or add up all your in. And so what we need is observed data, and that's what we collect during our experiment, and then our expected data with the E. There's different ways to get the expected data. It depends on what it is you're actually testing. Many times to get expected data, sometimes they'll just divide everything equally and expect equal values for all of their categories. Well, in the case of our M&Ms, that's not the case. Where we're going to get our expected values, we actually contacted the Mars company, and this is what they have their machine set for to put into the different bags of M&Ms that they manufacture. Last week we did plain M&Ms, so you will have noticed that the largest amount of the color blue was in that bag, and well, that's as should be according to what they say they put into the bag. They say it should have about 24% blue in there. That must probably be due to some marketing thing where people like the color blue. Orange would have been the next largest amount, with then green and then red and brown following. Yellow and then red and brown. I like red the best. I wish they put more red in there. Oh well. Notice the percentages are a little different for the different types of M&Ms that they do manufacture. So, like I said, in some cases, for their expected values, they might just divide everything equally for all the colors, like expecting the same amount of brown, yellow, red, green, blue, and orange, but that's not the way M&M does it. Mars company does it. So we got this to help us get our expected values. So out of the bag we did last week, there were 356 M&Ms in that bag. To get our observed values, we actually counted them up, or at least I did. And then to get our expected values, we still need to do it out of 356. So here is what the data should look like. Our observed data up here out of 356, and then the expected data, taking the total of 356 times each of those percentages. For instance, the blue was 24%, so 24% times 356 should have given you about that number. So notice that our observed values do not they're not equal to the expected values. So we do the chi-square test to see, is something weird going on here at the Mars factory? Is this like really, really off? Is it statistically significantly off? Then we'd probably need to do some further testing to see what's going on. Or is it just due to random chance that the differences in these variables is just random chance and nothing big is going on? So, like I said in my video, or in my information on Schoology, to use decimals for the expected values, it's going to get you a better chi-square value in the end. So go ahead and use those decimals. Yeah, I know you're probably not going to have 0.3 of an M&M, but that's all right. you'll get a better value in the end. So remember, with our equation, for each of these we take the observed value minus the expected value and then square it and then divide by the expected. So this chart just kind of takes you through that and allows you to write down each of these to help you out in our first trial in doing our chi-square test. So for instance, if I did the blue one, again, our observed value was 91 minus the expected value of 85.4. Then I would have squared that. Got this. And then divide by the expected value, and that's what this value is here, 0.37. I do that for all the rest. And remember, don't forget the final step. This symbol here means the sum of. So I would have needed to add up all of these to get my final chi-square of 7.6. All right, once we have that, our degrees of freedom is the number of categories that you have minus 1. So there were 6 colors of M&M, so minus 1. Degrees of freedom should be 5. All right, so we find that on our chart, 5 degrees of freedom. And we're going to use this column here. You can use other columns, but this is the column that in AP Biology we've decided this is the one we're going to use. You can use more exact columns if you like if you were doing human trials, you might want to use something a little more exact, but in our experiments in AP Bio, it's fine to use this one. So here's our magic number, what they call the critical value, 11.07. So then we take our chi-square value and we look, is our chi-square value higher or lower than the critical value? And in our case, with our test we did with the plain M&Ms, it was lower. 7.6 is lower than 11.07. So that means that we will accept our null hypothesis. In other words, that would mean there's really no statistically significant difference in our actual ratios. So any differences that we see in our different categories, it's just due to a random chance sampling error. Nothing too big of a deal. It basically means what Mars is putting in each of the bags is what they say, or at least it's very close or not statistically significant. If we would have had a higher chi-square than our critical value, then we would reject our null hypothesis. That means that something, again, might be going wrong with what they're doing to put the different colors into the bags. Something is awry at the M&M factory, oh my. Alright, so then in the last box, I gave you a template to use that you can use it word for word, just putting in your information. I accept my null hypothesis because the chi-square value of 7.6 is lower than the critical value of 11.07 for P equals 0.05 at 5 degrees of freedom. Alright, and I'm not convinced that you're very good at doing this yet. We all need a little bit more practice, so we're going to try it another time this week. This time we're going to use one of the different kinds. We're going to use the peanut M&M, actually my favorite kind of M&M. And again, I'm going to sort these into categories for you. And then, of course, I get to eat them when it's all done. Actually, I haven't even touched the plain ones yet from last week. So I think they're trying to tell me something here, that they're not letting me get into the bag. And there we go. So what I'm going to do is count these up, and then I'm going to put my data into the table. We're going to give it another try this week. And then we're also going to try using the chi-square test for some actual biology experiments, even some like we did in class, and some like we might have done if we got to stay in school this year. So I'm going to go ahead and count these up, and then I'll get back to you with the data. Alright, so I have all these sorted. It took me a lot less time to sort these because with peanut M&Ms, there's not as much room in the bag, so I get less of them, but they do taste good, so I'm okay with that. So I'm going to go ahead and count these up now. Alright, that did not take me long at all. Alright, so for our peanut M&Ms, for brown we have 12. That's my observed value. For blue, we have 18. Oh, there's our dominant color, blue again. Orange, we have 16. Green, 9. Red is 9. And yellow was 10. Now I need to add those all up. You can probably do it faster than I. Alright, so I've got 12 plus 18 plus 16 plus 9 plus 9 plus 10. Okay, I hope that is 74. Alright, there's our observed data for our new M&M experiment. Now you're going to get expected data. And remember, you're using a different kind of M&M this time. We're using peanut. So you need to use these percentages instead. Alright, use the peanut M&M percentages. And just like our experimental bag, you're going to use out of 74. So what's 12% of 74? 15% of 74, so on and so forth. And that becomes your expected data right here in this column. Then remember, once you've got that, take your observed minus expected, then square it, then divide by expected. Remember, use decimals. All right, and then in the end, don't forget the last step. Chi-square is actually the sum of all your categories. So add up the last row and put your chi-square in the corner. And I'm interested to see if we're going to accept or reject our null hypothesis this time.